Welcome to this demonstration of SpaceClaim style. Today I'll show you how I can create a new version of a medical device scanner. You'll see how I can turn an existing design into a new one, taking into account inputs from other design teams, how I can directly reuse data from other 3D systems, and how direct modeling using solids in SpaceClaim is a faster way to work than surface modeling. We'll import an older version of the scanner in from the neutral file format step. In SpaceClaim, we can open up geometry from neutral files like STEP and IGES to work with them as if I created them in SpaceClaim. We can also save them as SpaceClaim documents. I'll call this ID concept for now. To start, we'll focus on the old faceplate that's there. We're still in the conceptual stage, so I have a lot of freedom and flexibility to get rid of components as I try to work on a new look for the scanner. Notice that we can work with geometry directly as it comes in. We can pull geometry to change it or alter it, and also divide up faces to change it further. We can also move geometry around screen to translate it or rotate it into a new position. Additionally, we can go through and build intelligence into the model, or use temporary hints. This allows us to modify one side of the model and have the other side automatically update. These hints live with the model and can be turned on or off whenever you'd like. Next, we'll need to recreate a new area for our lens and the lights. If we'd like, we can drop back down into a sketch and create an area to place our future components. Once in 3D, these sketches can be used to create or cut away geometry. But I can also continue to build intent into a design, creating a quick pattern for the lights or changing the count depending on how many we'll need in our design. We can also quickly manipulate edges as well, dragging around on the edge to give it a better finish, or switching that to a chamfer. We can also update one pattern member and have all of the others update at the same time. After completing our design on one side, we'll probably need to take that and bring it to the other half of the model. Just as before, if I'd like to take part of my design from one half to the other, we can mirror it back across to the other side. We've made the basic outline for the faceplate, but it's still one solid model. We can cut our original model into two different parts, and also change some of the colors on our components so we can tell them apart a little bit better. But in addition to splitting our housing, we can quickly move our front portion to a new component and add it to our assembly. This is part of the power of direct solid modeling. In SpaceClaim, it's simple for us to slice and dice a model up. Notice in the structure tree how we can go from one solid and quickly cut it up into 4. We can also delete any solids we don't want or combine the rest back together. We can also create temporary lenses in the model by placing surfaces in their position. I'll color them red so we can see them a little clearer. We also might want to remove some features on the model to change its shape. In SpaceClaim, I can remove or defeature things by simply filling it in with the related geometry on screen. Our faceplate is looking pretty good now, though. And the final thing I'd like to do is to make the front look a little nicer. We'll just angle up the front face and replace it with a round to finish it off. In just a few minutes, we've converted our design and remixed it to have a new faceplate in place of the old one that was there. Now we'll be making some changes to our design based on engineering recommendations. They've sent us a placeholder for a 4th lens that comes in from the IGES file format, and they'd like us to incorporate it into our design and build the housing around it. They've let us know where it should be placed on the model, so we can move it there and dimension it from the other lens we already have. Now that we have it in place, we'll need to create some geometry around it. To see it a little better, I can drop down into a cross-section of the housing. Here we can add material to mark as a keep-out around the fourth lens. Also, cross-sections can be placed anywhere throughout the model. But also, these cross-sections we use in SpaceClaim aren't just visual. We can modify geometry in any section we place on the model. We can see the keep-out in the background, and we'll use that to sketch out the profile of our new scanner housing. This is just a preliminary sketch, and we could change it in the future. In fact, we can take this one curve and copy another one so we have multiple trajectories to create our new surface around. We might want to have a different trajectory, but instead of having to go back into the sketch and edit it, we can edit it directly in 3D, moving spline points higher or lower, or even removing extra points that we don't need to be there. After setting up a few guide curves, we can blend or loft between them using as many curves as we need. We can do this type of advanced surfacing to create multi-guide sweeps or blends or other surfacing. Now that we've created our new surface, we simply need to replace our old one with the new one. Now our new housing will encompass our change from engineering. And we can still go back and make other changes to the outer housing that might be necessary. The model would probably look better with a taper in the back, which we'll add after placing our new surface on the model. We can also add any rounds back to the model, which might be needed to add a little bit more style. The model is definitely starting to look a little bit more stylized. And finally, we can add the keep-out that we had placed on the model into our actual housing. The last thing we need to do for our model is shell it out for our proposal. This will give us a realistic design to show the rest of the team. Our housing is definitely starting to look better now. From an ID side of things, the only thing left to do is to look at the old grip. Luckily, someone else from our team designed one that I can use to replace our old design. The new one comes in from Rhino, and I'll use it to mix and match with my existing design. We can bring in designs from Rhino and work with them to add rounds or thin the model out. This allows us to go back and forth between the two systems to add or change geometry as we see fit. I'll need to add the handle into our housing, so we can slice and dice it up to remove the areas of intersection before combining the rest of the handle back onto the housing. In addition to adding the handle onto it, we can get rid of the area of interference that's going on with the trigger, deleting just that one area, or we can zoom in and create a slight offset so there's a tolerance between the trigger and the housing. In just a few short minutes, we've drastically changed and stylized our model for both aesthetics and requests from engineering. To document some of these changes better, we can go into a 3D markup. 3D markup allows me to compare different versions of our design. We can see the step version on the left and our updated design on the right. Here we can use notes or dimensions to call out the changes in the design. Here we're indicating our new housing accommodates our fourth lens. In addition to this, we could show color change face modes, which indicates which faces got changed by what color they are. In fact, we can also add a rendered version of the laser, so it will be easier to tell if this design will be suitable for market, and we can do so in one proposal. We've quickly seen how we can make quick, stylized changes to designs based both on aesthetics and engineering changes using SpaceClaim style. I hope you took away that direct modeling with solids is a fast way to do your industrial design. SpaceClaim makes it easy to work with my other design and engineering teams, and SpaceClaim lets me take existing designs and turn them into what I want, rather than starting from scratch. Thank you very much for watching.